So we're going to be doing now, we're going to skip the number 2 because that you can do when watching the video by yourself. We're going to move on to number 3, which is the hard one, where we're going to be drawing what's happening at the molecular level. So hopefully you watched the intro video of me doing a couple practices, but if you're still confused, watch this and I will go through each one of these and show you how it's done. Now I would suggest you watch one and then try to do the other ones by yourself or something like that. Or just skip maybe down here to like one that's harder that you want to watch and try to do these other ones because it's going to be a really long video to watch it all. But you're welcome to watch the whole thing if you're confused. So the first thing we need to do to look at the molecular level is we need to assign a color for each one of these. So if you're on Kami, you can just underline them and use the dot feature. I'm going to just use this little highlighting thing here. So I'm going to assign AG as a yellow, and I'm going to assign CL, how about we do it a green. Alright, so to draw these, you're going to have to draw certain dots to look at their molecules, alright, and the atoms. So first we're going to draw a molecule of AgCl. So in a molecule of AgCl, you have one Ag, sorry the yellow doesn't show it very well, and you have one Cl like that. Alright, so in this problem, we have the AgCl, but we have 2 of them. So you have to do this, but you have to draw it again. You need 2 sets of AgCl. That's what this is saying, 2 sets of AgCl. So this is one set. Now we need to do a second set of AgCl. So Ag and Cl. Alright, now we're going to get our arrow going. Okay, so now for this one, we have Ag by itself, and then we're going to have 2 sets of that. So we're going to do Ag by itself, but we need to do 2 different sets of it. So Ag with 2 sets, 1, 2. Then we're going to have plus, and we're going to do our Cl. And in our Cl, you'll notice that there's a little 2 down here. So for our Cl, we actually have to have Cl2. So in your molecule, it's going to have 2 Cls that are bonded together. So this is what that looks like. So you'll notice when it's a number out in front, that means they're going to be separate molecules. When it's a number in or right by it, a small number, it's going to be in the molecule. Alright, so this one, it was in the molecule. This one is when they're separate. Alright, let's look at another one. So again, you can pick whatever colors you want. We'll do Fe a color. We'll do Cu a color. And then we'll do SO4 a color. Alright, now again, the SO4 you're going to do all one color. Alright, so to draw this out, we're going to start with an Fe. We're just going to have one dot all by itself because it's just one Fe. Plus, now we're going to do CuSO4. So for CuSO4, we're going to have a Cu dot, and we're going to have an SO4 dot. Now these ones, we just need one of each dot because in this problem, we just have one of each thing. And there's also no other numbers in front, so it's just one of each thing. Alright, next we're going to have it we're going to have it be a Cu, so Cu is my green. So I'm going to do a green dot, plus, and then we're going to have FeSO4. So Fe, and it's going to be bonded with, because remember, they're right by each other with no plus sign, that means they're bonded together, so Fe bonded with SO4. Just like that. So that's how you draw the one. Pretty simple. Alright, the one down here one's going to get a little bit more dots, so stay with me. A little more dots here. So we need 4 different colors for these ones. So we'll do K. Let's do maybe a pink I. We'll do green again, PB. And then we'll do NO3. Alright, so first molecule is K and I together. So we need a K dot and an I dot together. So K dot and I dot. Alright, then remember, this molecule, we have it 2 times. So this is 1 time, we need to do it a second time. So do this a second time, K and I together. So now we have 2 KIs, 2 KIs. Plus, now we're going to do a PB NO3 2. So this 2 tells us we need 2 NO3s. So we're going to do PB with 2 NO3s connected to it. So we will do a PB. So that's going to be a green dot. And then we're going to do 2 NO3s, which are yellow, or these orangish dots connected to it. All right, that's that one. Now let's look at the other side of the arrow. So we're going to have a KNO3, so K is blue, so we're going to have a blue one connected with the NO3, which we decided was kind of this color, KNO3, and then we're going to do plus, oh sorry, I messed up. We did KNO3, but there needs to be 2 of them. This is only one of them, so we need to do it a second time. Alright, so we need to do another KNO3, K, and then NO3. Alright, now we're going to add those to this PBI2. So PB, and then again, this is I, but we need 2 of them. So we're going to have a PB dot connected with I twice. So our PB is our green color, and it's being connected to our I, but we're going to need 2 I dots. Alright, 2 I's for this PBI2. Alright, that's lots of molecules, but there it is. You can also kind of see the important part of doing this is so that we can see how when we undergo this reaction, we're breaking these bonds, and then we're reforming them in a different way. That's why we're drawing these visuals. We're not just drawing them for fun or to make you do more work. We're drawing them so that you can actually see how we're breaking these things apart, and we're reforming new things on this side using the same elements. Okay, this next one is the hardest one, but what we're going to do for this, instead of making you draw out all these dots, let's just assign some colors to each of these things. Alright, so we assigned some colors, so let's draw our dots. So we're going to have C25H12. So C25, you're welcome to do 25 dots. Alright, C25. I didn't exactly count, but that's around 25, and then this is H12. Alright, C25H12. For these ones, though, you're welcome to do this. You're welcome to draw one O2. So here's an O2, right, like this. O2. So you see we have O2, here's 2 O's bonded. We need 28 of those, so instead of drawing out 28 around it, you can always do like this, times 28, to tell me you're going to have this, but 28 times. Alright, then we're going to have our arrow going too, so now we need to do this CO2 here. So let's do a CO2. So we have one C, and it's being bonded to two O's. Alright, and then again, you can do 25 if you'd like. You're also welcome to do times by 25. So say we need this 25 times. Alright, let's do this molecule. It's going to be H2O. So let's do our H. And then we're going to have, we're going to do 2 H's. And then we need 1 O connected to it like that. Alright, and then for this one, again, you're welcome to say we need that times 6 times, just so you don't have to write as many dots. Alright, but again, we can see how we're taking this, breaking it apart, and connecting it in different ways. Alright, final one. Let's do our last little bit here. So we're going to have, let's do Mg, well, it's kind of a gross color. Mg, and we're going to do H, and then we'll do this Cl. Alright, so we're going to have Mg, it's going to be by itself, right? We only need one of them because there's no number down here, there's no number telling us more sets. Then we need an HCl molecule. So let's get our H. And let's get our Cl molecule. Alright, so we have one of them. This tells us we need 2 of them, so here's one, we need to do a second one. So do another HCl molecule. Alright, and now we're going to have arrow. Oh, you can hear the end of the bell. So now we're going to have an arrow, and we need to finish this off. So we're going to have H2, so 2 H's that are bonded together. 2 H's bonded together. And for this one, we just need one set, right? There's no number in front. One set of those 2 H's bonded together. And then for this molecule, we need MgCl2. Okay, remember this Cl2. So we need Mg with 2 Cl's bonded to it. So here we're going to take an Mg with 2 Cl's bonded to it. Alright, so this is your drawing down here. Also, just as a pro tip, if you're ever confused, you can also count up your dots. We have 1 Mg, 1 Mg. We have 2 H's, we have 2 H's. We have 2 Cl's, 2 Cl's. So it's balanced. This is a good picture, and you're set. So it'll be important to be able to draw these pictures out for the test and for quizzes and things like that. You'll have to go from the equation to the picture or from the picture to the equation. Alright, so this is some good practice. Let me know if you have any more questions.